Hello, everybody. The title of my article is Mathematical Modeling in the Classroom, a Socio-Critical and Discursive Perspective. There are three perspectives of this article: the modeling perspective, the analyzing perspective, and the critical perspective. In the modeling perspective, the author states that there was little research focused on the students' activities in modeling. There were different ways to organize and conduct the activities depending upon what the emphasis was. And different perspectives result in different theoretical frameworks and research agendas. So in the modeling perspective, we have these articles. One was Julie, these quotes rather. She distinguishes modeling as a content from modeling as a vehicle. So modeling content emphasizes the development of the competencies needed to model real situations, where modeling as a vehicle views modeling as a way to teach mathematical concepts. Julie's perspective is related to the pragmatic and scientific school of thought. The difference appears to be subtle, but the perspective has influence on what is and is not considered to be legitimate modeling-based teaching. Barbosa had a reflection on the role of mathematics in society. His statement was, since arguments and decisions in society are based on mathematical models, it's important that the students have the opportunity to discuss the nature and role of mathematical models. Kaiser, in 1995, used the socio-critical model, talked about the socio-critical model, and basically emphasizes that mathematics education must take part in efforts to educate students to be critical and engaged citizens. Modeling and application was a statement that I ran across, and I thought it was interesting. It says that this expression has been used as an umbrella term to denote all activities that link mathematics to everyday life and or other sciences. So under this umbrella are word problems, problem posing, open problems, and project work. The two main features of modeling are this, and these are ones that you'll be familiar with. One, the activity has to be a problem, not an exercise. It has to be a problem for the students. And two, the activity has to be extracted from the everyday or other sciences that are not pure mathematics. So we had an example of this modeling perspective, and it was a newspaper article that the teacher brought to the classroom. The article said the local government announced a program to distribute bean and corn seeds to farmers. There were 37.5 tons altogether, 25 tons of beans and 12.5 tons of corn seeds. According to the mayor, each farmer, and there were 8,000 of them, will receive 3 kilograms of beans and 2 kilograms of corn. The families of many of the students were beneficiaries of this program, so it looked like it was going to be a good example to use in the classroom. All right, so the teacher posed some questions. She says, what do you see in the news report? What is it about? And when the students read, they immediately saw a mistake. 37.5 tons would not be sufficient for 8,000 farmers if each received 5 kilograms of seeds. And this, based on this hypothesis, the families had different needs and should therefore receive different quantities, not all the same. So they observed and they figured that they were discussing how to create this model. The teacher asked what criteria will be fair. And so they developed another criteria based on the number of members in the farmers' families. The amount of seeds would be proportional to the number of people in each family. P represents the number of people per family, and S represents the number of seeds in kilograms. And as you can see, this is the way the model ended up graphically in our table. The fewer people in the family, the fewer seeds. The more people, the more seeds. All right, so the socio-critical perspective to modeling in mathematics education in this modeling example had this sums it up, sort of. It says in this activity, the students had the opportunity to observe and discuss how different criteria generate different mathematical results and provide support for understanding of current social situation. And so that sums up the first perspective. The second perspective was our analyzing perspective. And in that chapter, that section of the article was called Students and Modeling Activities. The diagrammatic representation view of modeling is used as a parameter to analyze students' modeling activities. Usually, this intention is to bring students closer to professional modeling. So we're going to remember this as we continue with the analyzers. That's the diagrammatic representation view. All right, so Houston and Neal and Mob has this empirical, they said the empirical data, they came up with 4 types of students in modeling. It says 1, those who neglect mathematical aspects. 2, those who neglect real aspects. 3, those who strike a balance between the two. And 4, those who consider both but disassociate from each other. All right, so Busey, Kaiser in 2003 and Busey in 2005, they said since students have their own experiences and beliefs, they may construct their model in different ways. For example, Christensen in 2001 discusses a case in which students were solving a population problem, ignoring references to the out-of-school reality. Students were instructed by the teacher to create and solve a real problem. In response, the students first thought of a mathematical content and then developed a fictional situation around it. The author refers to this as the inverse strategy. Analysis of this case led to the hypothesis that students were influenced by the school culture to adopt such a strategy. Still under analyzing the perspective, we have analyzing the transition from one stage to the next. So Ferry concludes that the differentiation among modeling stages is only theoretical, and it's difficult to distinguish between them empirically. He says that one must look at other conditions for the students' and teachers' work, such as time, teaching objectives, the school programs, and so on. Student skills are not deficient. Using the diagrammatic approach to examine their skills is the wrong lens for analyzing student practice. So since students and professional modelers share different conditions and interests, the practices conducted by them are different. Lavie and Wegner have strongly stressed that school mathematics represents another kind of knowledge than that of professional modelers. So the author proposes that considering school modeling as a practice that differs from that of professional modeling. So this diagrammatic view that they were trying to analyze it wasn't going to work. Finally, we look at the critical perspective, and that section was called "The Focus on Students' Discourse in Modeling Activities." First of all, discourse tells us something about internal processes. It's more than a translation of what's going on inside their heads. People really don't think with clear explanations. There's a socially shared language which regulates and guides what we think. So discourse and cognition are kind of inseparable. Discourse not only provides information about what the students say, but also about the perspective used, shared means, and the nature. Discourse refers to all types of languages, including signs, gestures, artifacts, mimics, and so on, and thus must be a point of research. And lastly, there were 3 types of discussion: the mathematical, technological, and reflexive. Mathematical refers to what we know in mathematics, which variables to use and how to graph it. The technological refers to the techniques of building the mathematical model. And the reflexive refers to the nature of the mathematical model, the criteria used in building and its consequences. In other words, what is the effect on the results of choosing only three variables? What criteria were used to select them? Are these results good for anyone? Discourse in action. There was a portion where the students were trying to figure out how many variables to use, and they came up with 9 variables. And the teacher had discussions with them. They had discussions with each other, and they brought it down to 3 variables. The discussion in bold up in here between the student and the teacher, that refers to the building of the model, and it's called technological discussions. The excerpts in italics in this section right here refer to the mathematical procedures, and they illustrate mathematical discussions. So there were 3 types of discussion: mathematical, technological, and reflexive. And in the pragmatic school of thought, technological discussions are privileged. The mathematical discussions are given priority from a scientific perspective, and according to the socio-critical school of thought, the interest is on the reflexive discussion. So the author states that there is much more that needs to be studied in regards to the mathematical modeling, analyzing, and critical perspectives in the classroom. Partial results of current research were discussed here, and other aspects are currently under study. To improve the research agenda on this theme, researchers may gain insights from broader fields of psychology and mathematics education. So there's still much to be studied here. And so we're going to close this section out because we are still building on what mathematical modeling actually is.